Okay, friends, here we go with day 2 of our bell ringers. So we're going to start by practicing multiplying by powers of 10. We're going to multiply 356 and 1/10 times 10. The easiest way to do this is just write your number, 356 and 1/10, and then take your decimal point and move over one place value position because I have 1 0 in my 10. So my product will be 3,561. And then when I multiply by 100, I'm just going to rewrite my number again, 356 and 1/10, add a 0 as a placeholder, and then I need to move my decimal point over 2 spots because I have 2 zeros in 100. So my product for this is going to be 35,610. Now when I divide by 10, my decimal point is going to move in the other direction. It's going to move to the left to make my number smaller. So my decimal point is going to move over one spot to the left, making my quotient, or my answer, 35 and 61 hundredths. To divide by 100, my decimal point will move over 2 spots. So my quotient will be 3 and 561 thousandths for that one. Okay, for this next problem, we're going to be converting centimeters to meters. So when we convert centimeters to meters, we're going from a smaller unit of measurement to a bigger one. Fly to horse, divide, of course. So I'm going 15 centimeters divided by 100 centimeters in each meter. So I'm going to take my 15 centimeters, add a 0 as a placeholder. Now the decimal point with whole numbers is understood to be after the ones place. Since I'm dividing, my decimal point needs to move 2 spots to the left. 1, 2. So this number will be 15 hundredths of a meter. Now when I convert from kilometers to meters, I'm moving from a bigger unit of measurement to a smaller one. Horse to fly, multiply. So kilometers are bigger than meters, so I need to multiply 9 times 1,000 meters in a kilometer. So that's 9,000 meters. Next, we're going to practice rounding. We're going to round 76 and 51 hundredths to the nearest 10th place, the ones place, and then the tens place. So let's see, here's the digit in my tenths place, and I'm going to use the digit in the hundredths place to help me round. 4 or less, let it rest. So since my 1 is less than 4, I'm going to just let it rest at 76 and 5/10. Now I'm going to round 76 and 51 hundredths to the nearest whole number. So now I need to just look at here's the digit in my ones place. I'm going to use the digit in the tenths place to help me round. 5 or more, go up a floor. Since this is 5 or more, my ones place will increase by 1. So that will round to 77. Last, I'm going to round 76 and 51 hundredths to the nearest 10. Here's my tens place. The digit in the ones place is going to help me round. 5 or more, go up a floor. So that means that my 7, when you're rounding to the nearest 10, that you're either going to let it rest at 70 or you're going to go up to 80. So in this case, we'll round up to 80. Next, we're going to talk about equivalent fractions. Now, when you're thinking about an equivalent fraction for something like 7/10, 7 is a prime number, which means we won't be able to reduce this fraction to find an equivalent fraction. That's not an option for us. It's already reduced as far as it can go. So instead, we can look at the fraction and think of it as being 7 out of every group of 10. So let's think about what fraction we would have if we had more than one group of 10. 7 out of every group of 10, so let's look at a group of 10. And let's shade in 7 of them. 2, 4, 5, 6, 7. Now, if I add another group of 10, now how many do I have all together? Now I have, instead of one group of 10, I have two groups of 10 for a total of 20. And how many of them are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 20. So that means that 14 out of 20 is equivalent to 7 out of 10. Okay, now we're gonna make our line plot. This is your time to shine, people, because I was just telling you I wanted to see greater accuracy with your line plots. One thing I want you to remember is to write your intervals underneath your x-axis, not on top. So when we're looking at these values, we have 2, 1 and 2/4, which is the same as 1 1/2, 1 3/4, and 1 1/4. Our smallest value is 1 1/4. So really I could start with 1 and just go up to 2 because I don't see anything bigger than 2. In the middle, in between 1 and 2, we have 1 1/2, which you could also express 1 2/4. And then in between 1 and 1 1/2, we'll put 1 1/4. And then 1 3/4 goes right here. Okay, so it looks like we have one of each. There we go. That's what your line plot should look like. You're going to make sure that you represent each piece of data with an X on top of the line plot. Okay, last problem. We're going to add 12 80/100 plus 11 10/100. And if you just think of these as being amounts of money, it's easy to add, because we know that when we're adding amounts of money, we stack up our numbers by place value. So our hundredths are in a stack, our tenths are in a stack, our decimal points are in a stack, our ones are in a stack, and our tens are in a stack. And then you just add normally. So 0 plus 0 is 0, 8 plus 1 is 9, bring down your decimal point, 2 plus 1 is 3, and 1 plus 1 is 2. So that gives us 23 and 90/100, or you could also write it like this, 23 and 9/10. They have the same value. Now, since we don't have money signs in our actual problem, I'm going to erase them in my work just so I don't confuse you guys. There we go.